Hi, this is Ken Urban for CSC 125. In this lecture, we're going to continue building our sort of bigger project here with the rectangle class. So what we're going to do is we're going to add sort of two things to this rectangle class. What we want is one called perimeter, and then another one called area, right? Notice first off that there's no parameters here. We're just returning a double. So because we've already kind of put all this stuff in here, so we can just kind of use the stuff that's in here and send things back. So I'm going to calculate both the perimeter and the area. As I talked about in the discussion, I'm also going to add a private function which is going to return a point called opposite corner, I guess. And because in order to determine the perimeter, we need this point, and then we need the point between them, and then we need this other point. So that's what I'm going to call opposite corner. I couldn't think of a better name than that. Maybe adjacent corner. Okay. We'll call it adjacent corner 1, and I guess that would be adjacent corner 2 if we need it. Okay, so those are the pieces that we're going to put in. So we've kind of defined what they are. First step, as always with programming, you always want our code to compile. It doesn't compile right now. So let's stick in prototypes. Double perimeter. Right, got in my squiggly braces. Double area. Put in my squiggly braces. These are both members of the rectangle class. Rectangle class. Almost forgot to put that in there. So, and the other one we have in here is terms of point, and it's a member of the rectangle class, and it's called adjacent corner 1. Oops. Right, so I have just little stubs of these functions, just no definitions or anything like that in there. Let's see if the whole thing compiles. Good deal. Okay, it compiled. Now I can start sort of thinking about it. I guess we're going to do the perimeter first. So to calculate the perimeter, I need to double the distance from corner 1 to adjacent corner 1 plus the distance from adjacent corner 1 to corner 2, right? So we're going to go kind of halfway around. So to start off with, let's just put variables in here. It's called distance 1 and distance 2, right? This is distance 1, and this is distance 2. So we're going to, after we calculate them, eventually we're going to return d1 plus d2 times 2. So let's make sure that we recall we're doing these as doubles. So I'm going to just explicitly put 2.0 in there. Just remember. So now I need to calculate d1 and d2, but I'm going to need the adjacent corner. So let's create point adjacent equals. Now I wrote this function down here to help do that. So that should give us the adjacent corner if everything works right. And I put in a little bit of code, so you know what? I want to actually make sure that this works. So for now, I'm going to create a point P, and I'm going to return P. And I know that P is going to be 0, 0, so just for testing, that'll be fine. So this will make the adjacent corner always 0, 0. It won't quite work out right, but just to make sure it compiles, we'll do this. Okay, compiles. All my syntax is correct. So now we can say here d1 equals my corner 1 dot distance 2 adjacent, and d2 equals my corner 2 dot distance 2 adjacent also. And I suppose I could have been a purist and put adjacent to corner 2, but that's fine now. Everything's still all pieced together. Okay, everything still seems pieced together. Now we need to calculate that adjacent corner. Well, we know that we're changing the x and y, so it'll have the same x as corner 1, and it'll have the same y as corner 2. You notice I'm using these accessor functions, get x and get y. I'm in the rectangle class. I can't access the data directly, nor would I want to. Right? I want to just be able to use the things that are in there, and if the point class breaks, I don't have to fix the point class and the rectangle class, just the point class. So I'm going to get x and get y, right? So I'm calling my constructor with information I've pulled out of these points, right? So it's going to pull the x out of this one, it's going to pull the y out of this one, right? Create a new point, and then return that point. So let's see what we got. So I'm going to go out here to main to test it. Right, so the perimeter is, let's see what we got. We'll run it. The perimeter is 220. Yeah, I don't know, that kind of looks about right. Let's see, we got 103 here and 8 there. So 103 plus 8 is 111, but it's half off of each of them. So 110, yeah, so the perimeter worked out correctly, right? Because, right, this distance work is done somewhere else. When we're thinking about building these, it's fairly easy. And the area, well, I mean, that's going to be pretty easy. So we already have all the numbers we need in the perimeter. Right, so I'm going to make an area function. Well, we already put the area function out here. We have it stubbed out. I'm going to just copy this code, stick it in here, and the area is, since this is parallel to the axes, I can just do that. Right? Since it's parallel, we know that this is a parallel to the x-axis, and distances work out, and all those sort of mappy things. So what do we got? The area is 760. Well, yeah, I need to test that a little better. So why don't we make this rectangle a little more reasonable? Let's have a rectangle from 1, 1 to 2, 2. That's pretty straightforward. I gotta close this window so I can run it again. And the area is 1, right? Because here's 0, 0, 1, 1 would be there, and 2, 2 would be there. So, right, it's a rectangle. There. We can make it 2, 3. Test it again. And area is 2. Perimeter is 6. Yep. 1 up, 2 over, 1 down, 2 back. Okay, so it kind of looks like it works. Okay. Thank you.